Today on CodeDependent, we're going to talk about some techniques of cartoon animation. So a little while ago, I was doing investigation into various aspects of traditional animation and how they might apply to GUIs for conference talk or a set of talks that I was giving. And one of the areas I wanted to look into was how the buttons worked in a gaming console that I happen to have in my living room and spend too much time with. And this particular console focuses a lot on user interaction. It's the Wii, and it has this new way of, you deal with the wireless remotes and you actually perform the actions themselves because the remotes know where they are, and much different than the traditional sort of thumb gadget thing. But what's particularly interesting to me in the context of this is how the UI interacts with the user. They aren't just static buttons on the screen. Instead, everything is sort of fun and alive, and it's a combination of things. There's audio and very sort of fun, perky sounds, but there's also interactivity of the UI itself. And so what I thought I remembered was when you pressed on buttons, they actually squished in, kind of like the Pillsbury Doughboy. They sort of reacted to the button pressing on them. And when I actually looked at the UI more in depth and spent a lot of quality time on very important academic research, I found that there were actually different interactions that they had, and that they didn't necessarily seem better one way or the other. The important thing about the UIs were that they interacted. It didn't actually matter as much the particular thing that they did, but the fact that they actually reacted very physically and tangibly to what the user was doing made the experience much more gripping and much harder to tear yourself away from for dinner. So I wrote this little application to show kind of what I was talking about there. We have two buttons here, and as you hover over them, you'll see as I move the mouse onto the button, they do something different than GUI buttons normally do. Normally they're there, and you hover the mouse over them, and maybe they change color, maybe they don't. But they don't actually normally change size and position, right? But this one's actually popping out saying, hey, click me, play me, I'll be fun. And the stop button is doing the same thing. And then when we click the play button, we get a different interaction. It actually pops out toward you. Now this is the one that I didn't expect. The one that I expected was on the stop button here, where pressing on it actually pushes it away from you, and then unclicking it pops it back out. Right? So you've got the physical reaction of pushing on the button and it goes away. But this one actually works in much the same way. The important thing here is not so much the direction that it moves, but the fact that it actually is moving. It's reacting, it's changing size, it's changing its overall appearance based on that click. It's a very interactive experience, very tangible, which I think is one of the key elements about this particular gaming console. So we can take a look at how this works under the hood. So we have a very simple application. All the intelligence is buried in these custom skins that I have for these buttons. So here we have two buttons, and they declare a custom skin class. So we have a fun button skin and a fun button skin 2. We'll just take a look at one of those, and you'll get the general idea. And we pass in a color for it and some positional information, and that's it. And then the skin itself, so let's take a look at fun button skin. This is for the play button. So we have 4 states declared. I basically took the skin code for button and I morphed it into what I needed for this particular animated version. So this is sort of a general approach that you can take in general with the Flex SDK, is you can grab any one of the skins in the SDK and then change the code to be what you want. So I've got other applications I've written where I wanted to go in and add general animated, a little bit more standard enterprise animated behavior to buttons. But just start with a standard skin and then add the stuff or change the stuff inside as you need to. So here I start with the standard skin, which declare these 4 states, and then I started declaring some animations. So in particular, what I wanted to do was say when the mouse was over the button, I wanted to change the Z property. So this is one of the new things in Flash Player 10, is the ability to position objects in 3D in Z, which is basically toward and away from the viewer. So I said, okay, when they hover over it, I want to have a Z position of -30. By default, that position is 0. It's on the XY plane. So if I give it a negative value, it'll pop it out toward the user. So I said, okay, when the mouse is over this thing, then it's automatically going to move into that state, and it's going to have a Z value that'll pop the button out toward the user. And when the user clicks on it, it's going to automatically go into the down state of the button. And for that, I want a negative value of 50. So we're going to pop it out further toward the user. And then when we go back out into the other states, then they'll reset to an overvalue of -30, or the value when the mouse is not even over it of Z being equal to 0. And then finally, we want to actually animate this transition. So when we transition between these various states, we're going to run different effects. So for instance, when we animate from the up state, which is the mouse is outside of the button, to the over state, when the mouse actually goes over the button, then we're going to run the over mover effect that we had defined, which is over here. So we have the Move 3D effect. Move 3D is going to automatically animate that Z property. It's going to animate both the rounded rectangle of the button and the label element, that text, and it's going to run for 150 milliseconds. And then this is an important one too. When you go to the down state, it's going to run the down mover. And down mover is going to animate on the same properties, and it's going to, on the same objects, target objects, it's going to run, again, a Move 3D because all we're doing is moving this 3D Z property. It's going to run for a duration of 100 milliseconds. Now, one of the important things to notice here is that the duration of effects, as well as the easing behavior, the actual sort of motion behavior that you want for an object, is highly dependent on what you're doing. In this particular case, if you have a longer duration, when you click on that button, it's going to feel incredibly sluggish, right? So what I really wanted was an almost immediate reaction to the click, right? I want it to pop out immediately. In fact, having no animation is totally appropriate, I think, for a click, because the click action is so fast that you really want immediate, tangible results. In this particular case, I did want a little bit of animation, makes it a little bit more fun, and the application is called Fun Buttons. So I said, okay, give it a short duration, make it animate, but not for too long, and also give it an easer that I call Fast In. And Fast In is basically going to be a cubic ease, so it'll be a cubic function, and it's going to ease out all the way, which means it's going to start very fast and then decelerate toward the end. And the combination of that short duration with the easing out behavior for the cubic function is going to give a very fast animation that reacts very quickly to the user's action. So it pops out pretty quickly. It's an animated pop out instead of an immediate pop out, but it reacts very quickly to the click, so it feels pretty good. The stop animation, the stop button is defined very similar in its skin, so I'll skip that one. I'll leave that as an exercise to the reader. And that is it. If you want to see the code for Fun Buttons or related applications, check out my blog at graphics-geek.blogspot.com.